Hi, everyone. Thank you for coming to our webinar on feature selection. My name is Ernest. I'm the founder and CEO of PredictNow.ai, which is a financial machine learning SaaS for the use of any traders, investment advisors, managers, or in fact, anybody in any industry. So just before we begin, please note that today's webinar will be recorded. So if you would, we will be sending you a link for the recording after it's finished. And also, please feel free to ask any questions through the chat window or the Q&A window during my talk. I might pause during the talk to answer your questions. So please don't feel free, please don't leave your questions until the end, although we will have 15 minutes of Q&A at the end. But if you have any questions, please feel free to ask right away, and some of which my colleagues here will be able to answer, and others I will be able to answer even during my talk. Okay, so without further ado, let's figure out what feature selection is. It's actually a very, very important technique in machine learning, because the power of machine learning is that you can initially enter as input as many predictors as you like in order to predict something. You know, we are talking about supervised learning here. So generally speaking, we will have a large number of X variables. You know, if you're thinking of regression, which is a very simple machine learning model, you would have a lot of X values trying to predict a Y value. But oftentimes, you would not know what are the actual X variables that are useful. You know, if you in a linear regression, if you include X variables that are useless or redundant, or even worse, collinear, you get very bad results in the regression. But more sophisticated technique in machine learning, such as random forest, which we use, you know, in PredictNow, we are essentially using a boosted decision tree random forest. This is less of a problem. Collinearity is less of a problem, but still, it would be nice to remove variables that are uninformative before you start to train the model. And feature selection is a way to remove these non-informative variables, the non-informative X values, in order to do what? In order to, of course, improve the predictive accuracy. So we, you know, if you include non-informative variables, very likely will introduce overfitting, and it will decrease your predictive performance out of sample. All right, so we want to apply feature selection to get rid of them, to improve accuracy. But there is another reason why we want to apply feature selection. The second reason is that in the process of selecting feature, we will apply a ranking scheme to the features. And using this ranking scheme, it will allow you to gain intuition about what it is that is affecting the risk and the performance of your trading strategy. That could be actually more important than predictive accuracy, because a lot of investment managers who are new to machine learning may not trust a black box. You know, so let's say we ask you to buy Apple tomorrow, and you would ask, why? It's so expensive already. So, you know, a lot of people would not trust their driving to the self-driving car for the same reason that they do not trust a black box to make their investment decisions. But feature importance ranking is a way to allow you to benefit from machine learning without entrusting it to a black box. It lifts the veil on machine learning because it will tell you what variables the machine consider important. You may or may not disagree with it, but that's information that you can incorporate in your own strategy. You do not need the machine to tell you how to trade, but the machine can inform you why it thinks these variables are important. Some variables may be familiar to you, others may be a surprise. So the idea is both to get confirmation and to get new insights into what are the financial variables that are important to determining the profitability of your investment strategy. You might have enough money to buy tons of alternative data, news sentiment, credit card transactions, and satellite imaging data that are transformed into categorical features, and so on and so forth, weather data, what have you. You might have 500 different variables. No human can understand what are the important variables and what are not. So feature importance ranking will rank them and give you a good intuitive sense of what are important to you. And maybe some of these variables are the ones that you have overlooked that you might want to incorporate into your base model. Now, here is a little bit of a technical slide. It tells you how feature selection is usually, what's the algorithm, the typical algorithm for feature selection. It's an algorithm called MDA, mean decreased accuracy. What it does is that for a particular feature, MDA will randomize the rows. That is to say, it will randomly map different feature value, different predictor value to a label. If this feature is unimportant, then who cares if it randomizes it? It will have no effect on the predictive accuracy. But if that feature is really important, if you randomize the rows, randomize the mapping between a predictor and its label for a particular sample, you will get a big decrease in accuracy. So the bigger the decrease in accuracy as you randomize this feature variable, the more important it is. That is the gist of MDA. You don't need to know too much about it, but that's the gist of it. There are other feature selection methods such as Lime and Sharp. They are readily available, but and they also perform slightly better than MDA in some respects. However, we think that MDA is good enough if we were to apply this cluster-based method to it, which is what we have written a paper on, and which we will describe today, and which is already implemented in our platform, PredictNow.ai. So we will focus on MDA. Lime and Sharp are great, but in our opinion, after you apply cluster-based feature selection, MDA is as good, if not better. So what is the reason that we have to improve on existing feature selection? Now, feature selection has been around for some time. It's not our invention. Why are we writing a paper on it? The papers that we have written on it is because of our observation that common feature selection method actually generate different rankings when you run it with different random seed. For example, if you permute, the random seed is needed for permutation of the rows, as you remember, randomizing the row. But every time you permute it differently, oftentimes it would give you a different feature importance ranking. Now, and that is a very disappointing result to us when we first applied feature selection. We were hoping that every time we rank it, we'll get the same important feature that determines whether our strategy will be profitable. Is it going to be volatility? We are hoping that every time it will say, oh, volatility is what determines your strategy in profitability. Or the commodity futures returns is what determines it. But unfortunately, every time we run it on different computer using different random seed, we get different rankings. That is a severe problem because it removes any confidence in this ranking, and it removes any intuition or interpretability of this feature importance ranking, right? So for example, let's say we are using a bunch of technical indicators to predict the oil ETF USO's return. Let's see what happens when we do that, okay? Applying straightforward MDA. Well, here with seed equals 0, we find that, oh, the standard deviation, the volatility of two-day backward-looking return is the most important feature. And the 5-day return is the second most important. Okay, you say, okay, well, that's interesting, you say. But wait a minute, let's try random C equals 1. All of a sudden, the most important feature becomes the change in the volume. You say, what's going on? The volume predictor was, ranked 1, 2, 3, 4, 5, 6, 7, 7 in the first ranking, right? This is where it was originally. But when you rank it using a different random seed, all of a sudden it becomes the most important ranking. You say, what is this about? It's a big mess. And that is common for any feature selection. You can use Sharp, you can use Slime, you can use MDA, and they are all going to give you different ranking every time you run it with random seed. It's not just our observation, although it is not commonly discussed until our paper that was published in the Journal of Financial Data Science. It was not commonly discussed. I have talked to industry experts on this, and some of them know about it, others don't. But even those people who know about it are using very ad hoc methods to deal with it. And what we have described in our first paper is a systematic method to deal with it. But what we described in our second paper, called cluster-based feature selection, is a much more powerful way to deal with this. After we apply cluster-based feature selection, this kind of randomness in the ranking, this kind of non-reproducibility is finally solved. And I will demonstrate how it is. Now, I see some questions from an attendee. So let me answer that. So the question is, why do you think that these simple features have any predictive value? Now, this is a simple example, so don't get me wrong. I'm not suggesting that these technical variables is going to be allowing you to predict the oil return. Far be it, far from it. But what I'm suggesting, this is a toy example. I'm saying that let's throw in a number of simple technical variables and let the machine learning algorithm rank them, see how they are affecting the outcome. And what we are seeing is that every time you run it, it ranks them differently. So maybe none of them are very powerful. Maybe the predictive accuracy is low overall. But what I'm saying is that no matter what, you can rank them, right? They may not have strong predictive power, but you can nevertheless rank them in terms of how important they are. And their importance ranking changes every time. Right, so, okay, so yes, Dennis suggested running multiple seeds and see what the average ranking are. That's a good idea, and that's actually what we proposed in our first paper. In our first paper, the averaging is done not on multiple runs, but on multiple permutation. We found that you have to permute them enough times. The default number of permutation, for example, in scikit-learn implementation or MDA is insufficient. And the default number of randomizations in Sharp and Lime is 1. They are also insufficient. Okay, so yes, one way to do it is to rely on the law of large number, run it many times, and hope that the average converges. And we do show that after you average it many times, the average is better than the individual sample, but that takes computation. So that is a rather difficult, no one wants to have to run everything 100 times and average them, right? So cluster-based feature selection is a way that will actually not only address this problem, but make the cluster much more intuitive. And we will make the groupings much more intuitive, which we will discuss next. Let's see. Another way to look at the variability of normal feature selection can be looked at from this chart. So you can see that, for example, what is the most important feature in one of our data set? You'll find that, for example, the top feature was ranked top, let's say 35% of the time, but it is ranked second, also about 35% of the time. And the third, it is ranked third 20% of the time. So, when you say, what is the most important predictor for your machine learning algorithm? There's no simple answer, because the most important feature is varies. And, if you look at the one that is picked as the most important feature, it was ranked as the most important only 35% of the time. The rest of another 35% of the time is ranked the second most, and the third and an additional 20% of the time is ranked as the third most important feature. And then for some of the runs, they are ranked even lower. So that's very disappointing, generally speaking. Okay, so as Dennis has suggested, one way of reducing this instability is to average over many iterations at different level of the algorithm. You can increase the number of permutation in MDA, increase the number of sampling in Lime, and increase the number of permutation in Sharp, so on and so forth. That takes a lot of computation, as I said. The second way is what we described in our newest paper, cluster-based feature selection. That paper was inspired by the cluster MDA that Dr. Lopez de Prado has described in his latest book. So the cluster-based feature selection is not our invention. However, the clustering effort, the clustering method that was described in Dr. Lopez de Prado's book is k-means, and we find that to be not as good as hierarchical clustering. And then that's what we implemented on our platform as well. So in hierarchical clustering, we start from the bottoms up. When you have this whole pool of features, let's say you have 500 features, okay. The first step is to group them into small clusters, maybe 2 features or 3 features in one cluster. And then at the next level, you group this 2 feature cluster into a bigger cluster. So at some level, you will have to stop, obviously. So at the level when you stop, you have big cluster and you have smaller cluster. And each cluster will contain features that are very similar to each other. What does similarity mean? Well, usually similarity is measured by the correlation of those features in the training set. But you don't have to use correlation. You can use other information theoretic measures such as cross entropy or variation or mutual information or a Kullback-Leibler distance, whatever. You can use whatever metric you use to measure similarity. But what we use in our paper is just simple old standby Pearson correlation. Okay, that works just fine for us. So the question, however, is at what point are you going to stop? For the details, you have to read our paper. Basically, you have to stop at some level, which create the quote-unquote best clusters. There are mathematical criteria for determining at what level of clustering you should stop. Okay, so now that you have clustered these features into similar features, how do you apply MDA? The MDA applied so that all the features within cluster are permuted together. Remember, MDA permute the rows of features. They randomize the mapping of the feature to a label. But this random permutation are now applied to all the features in a cluster at the same time. That is to say, you can imagine if you have a spreadsheet of where the columns are different features and the rows are different samples. You can imagine all these columns within a cluster being glued together. When you permute them, when you rotate this column, all these different columns move in the same way. That's how cluster-based feature selection works. Okay, and then after you obtain the mean decrease accuracy of these different features, the importance score that you attach to the features or to the is essentially 1 over the rank of the cluster. So you rank this cluster 1, 2, 3, 4, right? The most important cluster is rank 1. The second most important cluster is rank 2nd, and the importance score of those cluster is essentially 1 over the rank of that cluster. Very simple, nothing fancy. So let me see. There are some questions already. Yes, so Mark asked when to stop. Indeed, the stopping criteria is so-called cluster quality. It's based on the mathematical criteria called cluster quality. And to know what that formula is, please refer to our paper. It's available for download on our website, so you can look it up, the exact formula. So Dennis asked, is this for determining the coefficient factors in the end? Yes, this is for determining the ranking of the cluster, because from the rankings of the cluster, you can get rid of the ones that are low rank, first of all, and also, as I will show you later, you will gain much better intuition of what are the important groups of variables that are affecting the profitability of the strategy. We'll see that very soon. Can this strategy perform better than Spider? Again, what I described earlier is a toy example. Do not think that this is an actual oil trading strategy. We have applied to many live trading strategy, which some of the results we'll describe later. But this is not a seminar about trading strategy. It's about how to improve your trading strategy using machine learning, and more specifically using feature selection, and even more specifically using cluster-based feature selection. So, okay, let's see if there are many other questions. Yes, there is a last question. The clustering logic is based on linear relationship. Yes. So if you want to consider non-linear relationship, you can definitely use the information theoretic measures that I mentioned. For example, Kullback-Leibler distance, cross entropy, mutual information, and the like. Okay. So, all right. Now let's look at a data set that is outside of finance, because this is a standard data set in machine learning, and it is a very easy to understand data set. Basically, you have a problem that you want to classify whether a tumor is malignant or benign based on 30 features that are numerical features that are summary of medical imagery. Okay, so this is called the Wisconsin breast cancer data set. It is famous in machine learning literature. It's used as a benchmark for many comparison of machine learning algorithm. So you are welcome to, we described this data set in our first paper, and you can also download this paper from the author's website. So if we apply this technique to this public data set, you will see the following cluster. The first clusters are all geometry of the tumor. It is very understandable. They are like area, radius, perimeter. So we can apply a topic to it called geometry summary. Very easy to understand. And the second most important cluster is all about texture of the tumor. So now when we run feature selection on this same data set before, you will find that these features are all different every time you run the feature selection algorithm. They are not the same. But after we apply cluster-based feature selection, these two clusters, the geometry cluster and the texture cluster, are always ranked the top and the second best. Never change in ranking. It gives you much greater confidence that this feature selection algorithm is working, and it gives you much better intuition of what is important in determining whether the tumor is malignant based on the image. Okay, so let's go on to, so that's the conclusion from this particular example. Stability of the ranking, that's foremost, and the interpretability of the cluster, that's the second most the benefit. If you move on to finance data set, there's also a public data set. I have given the link there, but you can also get this link, this citation from our paper, both the first and second paper. And the idea is to predict the 1 month ahead SPX index return minus the risk-free rate, the excess SPX index return. The features that was used in this fundamental data set, in this public data set, are fundamental and technical factors such as dividend price ratio, earning price ratio, the volatility, and so forth. Okay, and we will see if we apply this cluster-based feature selection, what kind of cluster did it find? Once again, it finds very intuitive cluster. The top cluster that we found is fundamental variable. We call it fundamental variables, but this is the name we give it to them because if you look at it, it talks about earnings, talks about dividend, talks about the inflation rate, and so forth. These are clearly fundamental macroeconomic factors. And then the second most important factor are what we call the technical factor, things such as the volatility and the yield between investment grade and the high yield bond, for example. So these are, again, extremely interpretable cluster to a trader. And it hopefully will conform to your intuition that, oh, if you are predicting 1 month ahead return, maybe fundamental economic variables are more important than technical. That might change if you're trying to predict 1 day return. Maybe the fundamental variable likely will be completely unimportant, and the technical variable hopefully will be more important. You are welcome to download this data set from our website and try it on our system. Hopefully you will find clusters that are different when you decrease the prediction or horizon from 1 month to 1 week or 1 day. So let's see if there are any further questions that might be interesting. Actually, Hakishan, we are using silhouette score. So, you know, the clustering method that we use is based on silhouette scores. So I don't know that it is, you know, I actually haven't read about the ONC algorithm. Our expert here, Nancy, she is the one who actually did the heavy lifting in this research project. So maybe she has read about it, and I will let her answer it. I don't know if she's in a webinar today. I think she is not on this webinar today, but let me see if she is. Let me take a look so that I can promote her to the panel. If she is, let me promote her to the panel and she can answer it if she has experience with the ONC algorithm. Okay, so yes, but silhouette score is actually what we use at the back end of our clustering algorithm as well. One question, Philip asked, do you run a feature selection as a multi-step procedure? Do you train and then drop and then train again? Indeed, we do that. The cluster, the feature importance are measured on the cross-validation set, right? So once it's selected the important features, only those important features are used, the ones that are above average in importance score. Only those are retained, and we'll retrain the algorithm, retrain the decision tree on the train set. Okay, so yes, this is indeed a two-step process. So there are a number of questions about the cutoff criteria. That, you know, we probably have to take it offline. It's fairly technical. Maybe Nancy can discuss it, but you know, let's take it offline if we don't have enough time. Hierarchical clustering can be trapped in local minima. Well, that is also a you know, interesting subtlety. And again, I'll leave it to Nancy to discuss the subtlety of local minima. But it is not really a optimization algorithm, the clustering method. So I am not exactly sure what local minima we are, you know, talking about. But again, we will take that offline. So how sensitive are the cluster to distant metrics? That is a good point. That is a subject of future research, because currently we have only tested using correlation metrics. If we are going to test it with information theoretic metric, you know, maybe different. We'll see. We haven't done that research yet. You know, it's a fruit for thought, and you know, hopefully we will pursue this further in the future. So is this technique tested on data set with low signal to noise ratio? Yes. Exactly what I'm showing right now. We are testing it on 1 month SPX return, which is a public data set, so you can verify it yourself how well it does. And also we have applied internally to our own proprietary strategy, and the result of which I will describe next. Okay, so yeah, so a question is whether we rank, you know, once a cluster is determined, do we do further ranking within the features, within the cluster? And the answer is no. All the features within the cluster are treated equally because they are essentially what you can think of as collinear features, or features that are very similar, things such as 3-day, 5-day, 10-day volatility. They are all measuring volatility over different time period. So they're very similar. There's no point to rank them further, really. But you can, if you really want to, you can rank them using non-cluster-based feature selection. And we also offer that on our platform. So on our platform, you can first run it through CMDA, the cluster-based method. And then after you obtain the important features only, you can run them through non-cluster-based feature selection to rank them further. You can do so. Yeah. So we don't, there's a comment about the repeated training. There is no repeated training. Feature selection is always done as a two-step, right? The first step is always to select the features, and the second step is to drop the unimportant feature and retrain a model. That is the standard procedure. Every feature selection algorithm use that. So that is not a lot of retraining, because after all, the out of sample test set is not touch. So you are free to look at how the performance work out of sample. You don't have to look at the performance on the cross-valid data set, right? So you can always look at the out of sample performance, not the in sample performance, to see how CMDA perform compared to others. So anyway, let's go further. And we indeed have applied to our own strategy, the tail ripper strategy, that our tail hedge strategy that we run in our hedge fund. In that strategy, we use about 160 features for meta labeling. That is to say, we use these features to predict whether our strategy will be profitable the next day. If it is not, obviously, if the probability of profitability is low, we won't trade that strategy. If it is high, we will trade it. It has turned out to save us a lot of losses using this method. We have been running it for more than a year, and we are very happy with it. But we are currently continuing to improve it, because we want to apply better and better machine learning algorithm to this task of meta labeling. And in particular, we have recently implemented CMDA on it as well. So here's the performance chart. If you use all the feature, the accuracy is actually quite low. If you apply basic MDA, the accuracy of the model in predicting the profitability of our trades increased to 53%. Better than at random, but not great. If you apply CMDA, it improves it to 61% accuracy. Quite significant improvement. So as I said, the CMDA is already implemented on our SaaS. Feel free to try it out. It's free to try. And you can register for a free trial at our website. But now let's take a look at the as a demo. So I'll let our VP of Engineering, Dr. Radu Sebano, to run through a demo. But before I run a demo, let me take a quick look at any questions first. Yes. No, there's no important questions that I have left unanswered. So let me stop sharing my screen, and I'll let Radu share his.
Good evening and good afternoon. So my name is Radu, and now I want to show the capabilities of the platform that we have. So once you registered via our website with a 1-month free trial, you will reach this dashboard, in which you have 2 modes for doing machine learning. One is the train mode, and one is the live mode. Now, in the train mode, you construct a machine learning model using some input historical data. And in the live mode, you will construct predictions. You will have predictions on new data. Now, first of all, we don't have a model trained yet, so we will create a new one. So I will click on the train mode. And now you need to upload the data set. So as Ernie suggested previously, we are going to use for this demo, we are going to use the S&P 500 monthly returns data set, which will be available in the dashboard after this webinar for you to try it. The data set is ranged from January 1945 up to November 2019. And in the returns column here, you can observe two classes, 0 and 1. A 0 class occurs whenever the future monthly return is negative or 0. So we label it as 0. Whereas a 1 class occurs whenever the future monthly return is strictly positive. So for instance, in this one, in November 1945, it is indeed the case that the future 1 month return will be strictly positive. Now, the following columns includes both fundamental and technical macroeconomical indicators. And first of all, I want to point out where do the feature come from. And this feature, for a better explanation of these features, please consult this paper. It is called A Comprehensive Look at the Empirical Performance of Equity Premium Prediction. But just as an overview, we include dividend price ratio, dividend yields, earning price ratio, dividend payout rate, stock variance, treasury bill rates, etc. So now the idea is you are constructing a machine learning model, a supervised machine learning model using these features, which might be included in both fundamental and technical macroeconomical indicators. And we will have the returns as a as a target variable. So now let me just upload it and click on the next. Let me go to okay. And after you have clicked on next, you will have a form to complete for constructing a machine learning model. Basically, you as a user can customize it using different options, can customize the training. So first of all, you will need to input the name of the data target variable. In this case, this is it's called returns, right? Now you see here that the data file is under time series format, so I will click on yes. If you leave the option set to yes, you will make the feature stationary using the technique of fractional differentiation, which was popularized by Dr. Marcos Lopez de Prado. The target variable is under class format, since what you are trying to predict are two classes. So this problem is considered as a binary classification problem, but we also allow multi-class classification and regression problems. And the feature selection algorithm that we want to choose for this presentation would be cluster MDA. And for speed purposes, I will leave the level of machine learning hyperparameter optimization set to none, meaning that the model will be trained using some default values that are found in our user manual. So we don't actually do for this run, we don't actually do the hyperparameter optimization step. The size of the test set, I will deliberately put it as 6%, meaning as the first 94% will be kept for training, whereas the last 6% of data will be kept for out of sample predictions. Now, the reason for using this is because that will correspond to the 2016 up to 2019 data, which will be used for out-of-sample testing. The type of ensemble, I released the type of ensemble learning to the gradient boosted decision tree algorithm. Sample weights, probability calibration are different techniques that are used that you might choose to customize your model. But for this demo, I will leave it as the default values. I suggest to use the exploratory data analysis because this will allow you to find any outliers or errors in your input data. And in the file suffix name box, you just need to fill in a name for your machine learning model. So I will do just that. Okay. So once you are satisfied with it, then you can click on Run Model. And you see here that now it's performing the cluster MDA step. Okay. Now, once you have obtained the results, so if someone is interested in the size of the data set, I forgot to add that this data set is about 900 rows and for about 14 columns, right? So this is a public data set. So once you have received the results link, you will receive it either both via the email that you provided for registration at the registration step, and you have it in your browser. So once you click on that, you see here the results page section, and in the results page section you see information about both in-sample and out-of-sample data. Since it's a public classification data set, the predictive power is not great. You will see here that it's still better than random, but specifically for the test set, right, which is range from mid 2015 up to November 2019. Indeed, the accuracy is superior, but the AUC score, so we offer 3 performance metrics at the moment, the accuracy, the F1 score, and the AUC score. And all the performance metrics will need to be taken into account when deciding when the model is appropriate to actually be used in live trading. So for the test set, although the accuracy is good for finance, usually an accuracy greater than 55% is decent for finance. You will observe here that the AUC score is less than 0.5, i.e. the under curve score is quite inferior. So we cannot conclude that the model trained using the this SPX public data set is actually something that you would use for live trading. But nevertheless, I want to show the output of what you can get from this platform. So I want to point out that a good model is also constructing using good features. So if your features don't have predictive power, then indeed your performance metrics will not be the best. Now I want to go to the resources here. So first of all, you have some simple information about sorry, you have some simple statistics about your input data set, such as mean, standard deviation, minimum and maximum, and percentiles for every column in your input data set. Now I want to briefly go to the other outputs, right, such as the cluster output. So as Ernie mentioned, for this public classification data set, you have 2 clusters, one with importance score of 0.66 over 0.66, and another cluster which has an importance score of 0.33. So the feature are split into clearly defined clusters, and in the paper that Ernie and Nancy have written, they point out that the first cluster is referring to more fundamental indicators, and the second cluster is related to more technical indicators, such that stock variance and other things. And now I want to show you the feature selection list. So in the feature selection list, what do you get as output? So there are 10 features, right, which will be selected. And these features, okay, you might want to ask, how are these features selected, right? So first of all, you look at the cluster importance scores, right? And you take the features from that respective clusters whose cluster importance score are higher than the average, right? So in this case, the first cluster will be selected, and all the features inside of that cluster will be used for training the machine learning model. Okay. I will briefly go to the other output. So the performance metrics file, in the performance metrics file is used just for convenience. So in the performance metric file, you just get this simple information that is displayed here, but you might want to download your files at a certain point. And you might want to compare the performance of your models and the predictions offline. So this might come in handy. I will go to the actual predictions now. I want to go to the out of sample ones first, since we don't have much time and I want to show as much as possible. So regarding the predicted targets, right? What are the predicted targets? Basically, these are the labels that are going to get predicted by the model. So you get a simple CSV file like this. In the sense, you have one column with the corresponding months, and now you will have two columns. One is the true target, and one is the predicted target. In the true target are actual values. These are the actual labels from your input data frame. Whereas the predicted target, these are the classes which are offered by your predictive model. So you see here some of the months the model got it right. In some, no, actually in the test set, most cases the model had taken it correctly, but I will take, since the AUC score is not superior, that would mean that this result will be taken with a grain of salt, because we know that in this regime it had been a bull market. So most of the predictions will be labeled as 1. Okay. And regarding predicted probabilities, I think that would be that might come handy, because first of all, you might want to use the predictions per se, 0 or 1, profitable or unprofitable. But the idea is, since you might not like a black box model, you might want to look into the actual probabilities that the model output. So you might use this machine learning model techniques to size your trades. So you might want to look into using it as a risk management layer. So for instance, if your model tells you that there is about 60% chance of your trade being profitable, you might size your capital accordingly. Or you might also have it as a threshold, saying, okay, I'm not going to trade anything unless it's great, unless the predictive the model tells me that the trade is going to to be profitable with more than 65%. So you might use it for different use cases. Okay. Now I want to very briefly show you the live mode. So in the live mode, you perform new predictions for new data. So now I want to download the model file. Yes. Now I will go back to the main dashboard and click on the live mode. Okay. And in the live mode, I need to upload a live data set. Now, how does the live data set looks like? It is, you might use it differently, but usually in practice, it is you're training a model using historical data, and then you decide whether you trade or not. So in this case, for December 2019, I'm trying to predict whether the January, so at the end of December 2019, I want to predict whether the January monthly return will be positive or not. Now, you see the format here is consistent to the format of your input data set. Of course, the values will differ, of course, but you will see here that the returns column had been left empty, meaning that you don't know in advance whether your trade is going to be profitable. Okay. And once you, so first of all, let me choose that. I think this one. Yeah. Okay. And now you need to upload your model. And let me look at here. Yeah, I think this one. Let me look. Hopefully I didn't get it wrong. Okay, so I think it's this one. Okay, so I'm going to click on predict. And indeed, as output, you get two CSV files. In the first CSV file, you have the predicted targets, right? So for this month, right? At the end of December, I want to see whether at the end of January, the returns, the monthly return is positive or not. And in this case, it said, yeah, it's positive. Okay, so I might trade on that. Now, in terms of predicted probabilities, again, if you look at the confidence that the model has in this prediction, it says, oh, over 90% chance of your model being profitable, of the returns being strictly positive. And with that, I will conclude this demo. And thank you very much. And please let me know if there are any questions. Thank you.
Thank you, Radu. Let me go back to share my my screen. Okay. Yes, and we are going to answer some more questions. I see some of them already posted. So one of the question is who cares about accuracy score? What about Sharpe ratio and profit factor? Well, those are backtest metrics. So the outcome of a machine learning is merely giving you the probability of success of your trade. How you use that for capital allocation, for leverage determination, for trade sizing will be your problem, not ours. And you will use this prediction output on any backtesting platform, Quant Connect or Ninja Trader or Blue Shift, and whatever your own proprietary trading backtesting platform, to find out how this prediction can be used to improve profit factor and Sharpe ratio. So backtesting is a separate issue which we don't actually deal with in this particular product. We have partner firms that will deal with that essentially. Okay, so another question is, do you retrain the model every month? That's an excellent question, Kinsley. So oftentimes we do, but there are occasions where we don't. For example, we find that retraining the model on data in the last quarter of 2020 is counterproductive because of the exceptional events happening. The last 4 months have been quite exceptional up to January. If you have been reading the news. So actually using those data to train your model is counterproductive because we don't expect those events to repeat itself going forward. So training using the latest data is not always ideal. Have you tried this with Numerate? No, that's the answer. But we are not. We obviously are applying this system to our own trading strategies. We have our own capital. We do not need Numerate's capital to trade. We have currently 8-figure. Is it 8-figure? Yes, 8 figures of dollars to apply this on. So we have no need to use their capital. Rate of success, yes, rate of success is irrelevant. That's perfectly valid observation. Backtest is your business, not ours. We only provide predictions and probability of success. So yes, so Dennis said, can we use this to predict the precise share price? Yes, we have. This system actually can also do regression. So what we have demonstrated is using it for classification prediction to predict whether a trade will be positive or negative. But if you want to make it to predict the actual magnitude of the trade, you can do so. We actually have a proprietary technique that we are going to publish after we file a patent to describe how you can use magnitude prediction to do something very neat, which we nicknamed CPO. It is not a commodity pool operator, which we are, but it is a parameter optimization technique that I think it's very neat, and we will disclose after our patent filing. So okay, let's see what else there are. So Ray has asked whether this lends well to non-stationary features. That is a very good point. If you enter non-stationary time series features, we will perform fractional differentiation or integer differentiation, if you like, through our platform. So there is a option to choose which designate your input as time series, but the time series has to be regular bars. So it cannot be tick bar, it cannot be volume bar, that sort of bars, but it has to be regular time bars. And we will perform fractional differentiation on it if you want us to. Yes, Pauline asked, I should call Professor Trump, because I know that Pauline is a professor of finance at York. So Pauline asked whether this improves on something simple like iterative regressions. So now that is, we are not saying that, we obviously haven't compared this method to every other machine learning method, that are existing. We have mainly compared with the traditional MDA that is used mainly for feature selection in random forest. So it could well be that stepwise linear regression might be better or might be worse. My guess is that when you have 150 to 200 features, any sort of stepwise regression will start to fall apart because of the non-linearity present in the data and the massive amount of collinearity. But yes, it's true, we have not compared with stepwise regression. So no, we are not trying to patent machine learning. We are trying to patent a specific method of using machine learning that we have not found mentioned anywhere else, and that we thought is going to be really, really powerful for a lot of traders in particular. So anyway, so that's a on the page where I show great OOS result. Error bar is a very good point. We provide error bars on, I believe, the regression result, but for the for classification result, Nancy or Radu can correct me. I believe that it is only the probability that was displayed. We do not have error bars on the probabilities themselves. So elaborate more on the SaaS. So yes, so the SaaS, you can try it out. So the best way to find out about it is to try it free. You can register for a free trial here, as Radu has already here. right? If you go to register, you will find it on free trial. So essentially, it will implement whatever we have discussed today. You will have access to. On the commercial side, after 1 month free trial, the basic subscription is $100 only, 99 to be precise. But if you want to use our API, which I'm going to display next slide, the fee will be $1,000, and that will increase because we will be implementing data integration. We will be offering proprietary features. So right now, what you get is software. Although this software is not something that you can find elsewhere, because I don't know of any other commercial package that implemented hierarchical clustering in conjunction with feature selection. But in the next month, we will integrate US company fundamentals pre-engineered features, so that you can select those features and add to your data set very easily, seamlessly, without any of trouble of creating the data set. So at that time, price will increase 50%. So, but for any, so I'm going to sound like a salesman for the next minute. For anybody who sign up now, they will be grandfathered in. They will continue to enjoy the current rate of $100 for self-serve, basic service, $1,000 a month for premium service that has API usage, plus 5 hours of professional service from our expert team. Our expert team consists of me, Dr. Stibano, and also Dr. Sergey Brilov. Sergey Brilov is a PhD in math from MIT, and he has consulted for major financial institutions, Bloomberg, Morgan Stanley, Barclays, the list goes on, for the last 10 years, and he will be available as part of the professional service team. So, but to get all that, please give it a try first. The API is available in both REST and Python format. So you can actually access it from any language because it's a REST API. But if you use Python, it will be seamless also. Yeah, so that's what the SaaS is about. The NAN value, that is a great question. Actually, today I was talking about that. The algorithm can handle NAN, no problem, but there are other subtlety with NAN. Sometimes you want NAN values to map to your existing data set. You actually want null value, for example, for days that you don't have trade. Let's say your data set is based on mark-to-market return. You will be able to still predict the profitability of a trade, even for those days that does not have actual trade. So yes, NON can be inserted, and we are actually going to present a better way of handling it so that you can retain all the NAN in both input and output. Yeah. So, so 8 figures AUM, that's a very good question, Anom. Why are we selling this? 8-figure AUM is considered a pittance in the hedge fund industry. Any investment manager with any self-respect would not even mention it, because typically 1 billion is the minimum AUM that you can make a living on. So, there's like 8-figure AUM is considered amateur. So I admit that we are merely amateurs in the hedge fund space. We have not increased our AUM to 10-figure, which is the minimum needed for a decent living. So that's why we are also launching it as a risk management platform for other managers, because it does not actually compete with our system. We are not hoping to generate alpha. Very important. We are not generating alpha. This is a platform for financial machine learning risk management. We're hoping that you're using it for improving your current strategy, which we will not have access to, not to directly generate alpha. Because let's be honest, if everybody's trying to predict whether Apple is going to go up tomorrow, if we know how to predict whether Apple is going up tomorrow, we are not going to tell you, and this system is not going to tell you whether Apple is going up tomorrow necessarily. It is trying to predict whether your own private strategy is going to be profitable. That is the most powerful application of machine learning that we have found ourselves. We internally have not actually found a great way to use machine learning to predict directly the market, right? Because of the low signal to noise ratio. Let's be honest. Some people can, I'm not saying that you can, but it is very difficult. What we have found successful is to use machine learning to improve your existing strategy through a process called meta labeling. That process has been discussed extensively on our website. And of course, the name was given to it by Professor Lopresti Prado. That is nowadays one of the standard use case of applied machine learning finance, not to directly generate trading signal, but to veto your existing trading signal, to apply proper sizing to your existing trading signal. That is the preferred, recommended use case, not preferred, but recommended use case. The API can handle large data set. If you want to use MATLAB, you can use our REST API. We will work with you because with premium subscription, remember, it is a very tight relationship. You are not left on your own. We will have a professional service team to help you integrate. So if you want to use the API in MATLAB, we can help you make it work. Essentially, it is a HTTP call to our API through our REST API, and what returns is a JSON file. But the technical details, I'm sure Radu can handle it better than I can. Are there unit roots in price series? Well, as I said, if you create a price series that is non-stationary, we will fractionally differentiate it if you wish to make sure that it's stationary. Thank you so much, Giorgio. You asked, are the probability? That's a very good question. I'm glad you mentioned it. So we do provide probability calibration as an option. However, to let you on a little secret that we found is that it's not that important to determine accuracy. Probability calibration only important when you are using edge cases, like when the probability is near 1 or 0. Well, in trading predictions, except in March 2020, the exceptional circumstance happened in February, March, and April 2020, when some of our probability go above 80%. That is true. In those exceptional circumstances, probability calibration is important. But generally speaking, you don't get probability that is more than 60%. It will be a great day if we say that, oh, your trade has a 60% probability of success. Usually it doesn't do that. Usually 55%, 56% is what you get. In exceptional circumstance, you get an 80% probability back in March 2020. And those are the times you may consider using probability calibration, but generally speaking, it's not that important. So let me see if there are any additional questions that I haven't answered. But no, I think that time is running late. I hope that I have not delayed your lunch too long. So thank you very much. This webinar will be has been recorded, and you will be sent a link if you want to review it. And yes, please do feel free to give it a free trial at our website. And have a great rest of the weekend.